Hello everybody, this is Todd Frazee again, and this is the training tutorial to do the assembly of the large vise stop. So the assignment in Fusion 360, in Canvas is the large vise stop assembly 2. And you're going to take three components that you should have already modeled. That is the vise block, the vise bar, and the vise rod. And we're going to bring those together in an assembly, and we're going to learn how to download the models from McMaster-Carr directly within Fusion. Now there's McMaster-Carr and some other vendors allow you to download models and then you can bring them in. But what's nice about Fusion 360, they've worked something out with a few of the vendors that you can actually download the models without leaving the Fusion interface. For this to be successful at this particular exercise, you're going to need to have the three models completely done, and they should be as accurate as you can to size, or the components won't fit. So you should have the bar that looks like this, the stop block, and it should have a threaded hole in one side of the slot and a counter bored hole for a 1032 screw. If those features are not correct, your parts are not going to go together correctly. And finally, the vise stop rod. We got to make sure that this is a 1/4 threaded hole going all the way through. Now there may be some semantics in the model I have. I have features like corner rounds, chamfers. Those are nice features to have the model complete. But to complete this assignment, you really need to just make sure you have these three components with the major interface faces where they interface with each other to size. If not, go back, correct your models, and you'll be more successful at this project. Alright, we're going to start off. You don't necessarily have to have these running, so I'm going to go ahead and close the individual models. And we're going to start off with an empty file. This is going to be the file that we're going to name as our assembly level. So we will use it as a container. So first let's save our model, and we're going to call this the Vise stop assembly. And you should have your data panel open, and it should show the different models that you created. And we're going to start with the vise stop bar. That's the part that mounts to the actual vise, so we want that the first component, and we're going to fix that in place so that it is stationary. Now the orientation doesn't have to be exactly the way I have it. This would be actually, if it was mounted on the back of the vise, you would be looking at it from behind the vise in this view. I'm going to leave it this way just because it's easier to see the components that you're adding onto it. Okay, so we don't need to move this one around. We just bring it in to where its origin is and select OK. The next step, you're going to right click on the model in the tree, and we're going to select the very first item, which is ground. What that does is it fixes this component in the coordinate system, so everything else can move, but it'll be in relationship to this part. It stays fixed. So your primary component you tend to want to have is your first one and have it fixed. And in general, you're not going to fix any other components. Otherwise, you won't be able to move them around and make adjustments. You notice there's a link there. Wherever this file goes, the individual models that were put into it need to stay in relationship with each other. And that means there's a link between this file and the individual model file for this component. Okay. So next, we're going to import the next component that mounts to this piece. which is the Vise stop block. So you can just simply drag it from your data panel into the working space, and right now it's overlapped with the other model. Move your cursor over till it turns into an open palmed hand, and you can drag this thing around, and you can rotate it and do different things. So I like to go ahead and rotate it so that it's in an orientation similar to how it would mount in the model. Okay, it doesn't have to be, but it helps with your visualization if you do this. So here I've rotated it 180 degrees in one axis and 90 in the other, and I'm going to select OK. Now in SolidWorks, to bring the relationships between these two components, it's called a mate. In Fusion 360, it's called a joint. So it's this icon up here, and they've made some recent changes to the joint menu. So if you've been using Fusion, it's going to look a lot different, but I think it actually works a lot smoother. So what we want to do is we want to create a relationship between these two components based off how they function. If the bolt on either one of these slotted holes is loosened, it's designed to slide back and forth freely on the rod. So we want to mirror that type of motion and that type of relationship. We're going to select joint, and it comes up with this joint dialog box. It's going to ask you, and then one of the components will go to a grayed out view. This means that component 1 is the one that you see in full rendering. And it's asking, okay, what surface, what part of this component do you want to make a reference on component 1? You have 3 options that you can toggle through here. The first one is simple, and it allows you to create a relationship between a plane, an edge, or a vertex, or a point to align the components. And the little circle with a half circle inside an icon is the snap point for that relationship. The next one is between two faces, and it creates a joint origin centered on between two faces. So if you wanted a pin to be centered on a slot, that would be one way to do it. And then there's a two-edge intersection where you can pick a theoretical point at the theoretical intersection of a couple edges. In this case, we're going to use simple. So we're going to select the cylinder, and the snap point will be the right end of the cylinder. You have 3 different places your snap point can go to for the cylinder. It's on one of the hole, the opposite end of the hole, and if you're tricky, you can get the center. I want to make the reference on this end of the hole, and a little tiny box shows up. Sometimes it's easy to miss, and it defaults to what's called rigid. This would align the component rigidly in its known position in orientation to your 2 selection points. It won't be able to move, slide, or pivot. The relationship of this part to this part is that it needs to be concentric to the rod. It needs to be able to move back and forth. So I'm going to select the fourth option, which is cylindrical. Let me explain what each one of these do. So again, rigid is just a solid, as if the components are glued together or pressed together. We have revolute, which allows rotation in one axis. We have slider, which allows the item to slide in and out of the references across whatever you've selected. And cylindrical allows you to have control in both revolute and slider directions. A pin and slot allows you to pick references as a cylinder and a slot type shape. So it'll center it in the slot and allow it to slide back and forth in it. There's planar. It only allows the thing to be joined in a planar fashion, but doesn't restrict its motion along that plane. And ball similarly can basically spin in 360 degrees in any axis. So we're going to pick cylindrical because we want to slide along one axis and rotate around another. All right, now it's asking, okay, I have this hole. What is it going to spin around and slide across? And it's going to be the cylinder of the shaft. And I'm going to select a endpoint that lines up with the limit of the travel of the block based off my first selection point. So we want this to function by sliding along the cylinder but never slide completely off the rod. So select the snap point of the end, and it's going to go through this funky little simulation, and it kind of shows the motion that's allowed for that joint. Okay. We're going to put in a negative value because the arrow is pointing away from our rod, but we're going to put in a negative value of the travel that this component is allowed to travel along this rod. So the distance should be negative 3.75. Oops. 375. And that gives it a reference from its snap point to an offset of where that component can rest on the opposite end of the travel. We then will select OK, and then right click down on your history, right click on the joint. So we're going to edit the joint limits. Okay, we don't want to limit the rotation. We want the rotation to be able to spin 360 degrees. So right now, if I were to take this part, I can basically slide it even into itself. Okay, we don't want to do that, and we can spin all the way around. So we don't want to limit the rotation, but we do want to limit the travel back and forth. So you're going to right click on joint, edit joint, and we're going to leave rotation alone. We're not going to put any limits in it. And we're going to select the slide. We're going to limit the sliding action of this. We're going to put a minimum of 0 and a maximum of 3.375, which should bring us to the end of the rod. Now if we animate this, it'll show what the block can do. It now can only slide in between those 2 points, and we'll hit OK. So now we can spin it, we can rotate it, but it's not going to come off the rod, and it's not going to come banging into the square section. All right. Our next mate is going to be the next component that we put in, and it doesn't really matter what orientation is in, but I'm going to put it in the vertical orientation. And we're going to open the data panel again and drag in our Vise rod. Vise stop rod. Okay. Again, we have the opportunity to move it in space. It's freely moving right now. And we want to orientate it as if it were going into the components that it's going to mate with or have a joint with. So I'm going to go 90 degrees, and that aligns it with roughly with the cylinder and the hole. Select OK, and we're going to do something very similar to what we just did. We're going to go to joint, and this box will pop up. You want to select capture position. I wish it could be disabled, but apparently it can't be. And in this case, we're going to select the cylinder, but we're going to select the end point of the end without the flat, and then we'll select the corresponding end of the hole that it goes in. and it'll go through a quick animation of how it can move. We'll select OK. Okay, so we have this cylinder that can now slide back and forth, and it can rotate. But we want to do the same thing we did to this other component, and we want to limit its travel. So we're going to give it the distance between the snap point that we selected on each component, how much it's allowed to travel. So right click on the joint, we're going to edit joints, limits, we're going to leave the rotation unlimited, and then we're going to go to the slider, and we're going to put a minimum of 0 and a maximum of 4 inches, which will allow it to slide the effective area of the rod. If we're to animate it, you should be able to see the distance it's allowed to travel. And we'll select OK. And now we have this functioning the way we would hope it would function. That's all its effective range. Now let's make sure we saved. We've now done a basic assembly. The next step is to add our hardware. And so if we look back at our assignment, we have to find a 1/4 20 black oxide set screw matching the length of the measurement in lab, which was 2 inches in length. We need to find a 1/4 20 zinc plated nut, and then we need 2 10/24 black oxide cap head screw machine screws. So here's what we're going to do. We're going to highlight the description of the screw. So we're going to highlight 1/4 20 black oxide set screw, and you can hit Control C, or you can right click and say copy, and it'll copy that text. We will return to Fusion, and we are going to insert a McMaster car component. Select on the link, and it takes you directly to McMaster Car's website. We can then use Control V to put the description in, and we get set screws. Now it's giving a lot more options than what we selected because they have them. So we're going to go over to our thread size. I'm going to select our thread size first. So we're looking for a 1/4 inch bolt with a 20 threads per inch pitch. Okay, and there we go. We select that. And then we want it in inch, and it's going to be regular steel. That's the only steel that's allowed to have black oxide. And our length is 2 inches. Right here. And it's a unified national course. It's going to have a black oxide finish, and we want a hex drive, so a headless with a hex drive, and that should match the description of what we had in the lab. Now the tip type, we're just going to go with a flat, and we've now narrowed down to a single set screw that we can use. This would be if you were going to order the part, you'd have your McMaster car part number. You're now going to select on the product detail, and you notice it has a little cat icon. If the item at McMaster Car has this CAD item, they have a dimension drawing, and a CAD model you can download. Select on product details, and it's going to take you to a better representation of what you're buying with all the specifications that it meets. If you wanted to order, you can go ahead and do that here. We're going to scroll down, and there's the dimension drawing. And you're going to switch your file type to SAT for Fusion. Now, several of these are universal formats. I believe Fusion 360 will only take the SAT or a step file. There's also IGES file, and I'm not sure what the EDRW is. Or you can have native SolidWorks. The SolidWorks is so popular that they offer it for you. And you want the 3D version. So we're going to select SAT and the save icon. And you're going to have that component just pop up right in the file that you have open. And the name will be, the description will be the part number and some sort of description. So it's a non-marring flat set screw. And so this is really nice because when you go to order your parts, you already have the part number. Now let's orientate this set screw in the orientation that it would be in the vise stop. So the flat head would be facing the vise, and it goes inside this hole. So I've rotated it 90 degrees so that the wrench side is facing outward, and we'll hit OK there. And now you can drag the component over closer to where it's going to be located. Now, fully threaded features are a little difficult on the joints. It's difficult to pick up on the thread because it's not really cylindrical to the hole. So what we're going to do is we're going to select joint, and we're going to capture position, and our first component is going to be the screw itself. And we want to look for something that's actually round on this. There's not much that's perfectly cylindrical. And our options are, on this end it's the flat tip, and on the opposite end it looks like it's the edge of the drill point, although I'm not sure if I would trust that, or it's this edge here. Okay, so I'm going to select this radius, and it gives you the snap point that's over in the center, but it'll be lined with the face of what I select. Now I'm going to go over to the hole that it's going into and select right on the edge of the hole, and that'll give us the cylinder. Okay, and it's showing its motion. Okay, and at this point I believe we can just select OK. And we're going to right click on that feature, the joint, and we're going to edit the joint limits. So we're going to have a minimum, the rotation we're not going to limit, so we're going to allow it to rotate. If you want to get tricky, there's a way to put it in a ratio so that it actually looks like it's threading in and out. I'm not going to cover that, but we're just going to leave that at its ability to rotate. We're going to put in slider, and we're going to put a minimum of 0 and a maximum, and it's 1.5 inches of travel. So our minimum 0, maximum 1.5 inches. So we can animate that, and it shows the thread traveling its minimum maximum limits. Is that okay? Now let's import the next item on our list. Our next item is a 1/4-20 zinc plated nut. So we're going to copy the description, and then we'll go back to Fusion 360, and again we're going to go Insert, McMaster Car Component, Control V on your keyboard, should be paste on a PC, and we're going to hit Enter, and we get nuts. Okay, so we're going to pick a 1/4-20. We're going to have a regular hex nut. System is inch. UNC is coarse, which is what we want. We're going to go with a standard hex profile. We don't care about the grade. For this application, we're going to do zinc plated. And that's about all we need. It'll give us all the different options. And it looks like we have different options based off the strength of the thread. I think grade 2 or 5 is fine for this application. We'll just go ahead and go with grade 2. There may not be a cost difference. And you want a standard thread. You don't want the reverse thread. So, all right. So we'll go to the CAD symbol under product data. Again, scroll till we see the drawing, and we're going to download a SAT. So select save, and there's our nut. We're going to move it over, and we're going to rotate it 90 degrees, or it might be a different angle for you, until it's oriented towards the set screw. We're going to hit OK. And now we need to create a joint between these. Capture position. Let's find something round on this. Let's use this side, and so our snap point should be in the center. And then we'll go back to our set screw, and we'll use the very end in its center. Okay, so there's our threaded screw animating. Now technically this could travel whatever distance it needs along this screw. I think what I'm going to do is, just for the purposes of this, we'll go ahead and hit OK, and we'll right click on the joint and edit joint, and I'm sorry, we're going to go edit motion, edit joint limits, and we'll just go ahead and limit the travel on that screw to 0 degrees, and we'll limit the slide to 0 inches. In reality, that can be adjusted, but it's something that would be relatively fixed, and it allows us to go back in and change those parameters. So here we go. We've got our assembly here, and we just have 2 more components. It's 1 more part number, but 2 more components to add in. So we need our black oxide screws that go in these 2 holes. Alright, so we have a 1/4 20 screw, and our length of the screw, overall length of the screw below the head, needs to be about 812 thousandths. We're not going to find a screw exactly that length, most likely, but that's the ballpark we need to be in. So it needs to be that long or slightly longer. And there's only thread on the second half of the fastener, so we could have the bolt doesn't have to be fully threaded necessarily. Alright, so we're going to close that window. We're going to go back again to Insert, McMaster Car Component, and we're going to put in our description from Canvas, which was a 1024 black oxide cap head machine screw. Okay, that brings us to cap head socket screw. So we want the socket head screw type. We want the 1024. So number 10 with 24 threads per inch. It's a coarser version. And we're going to do a standard head on that. and it asks for black oxide. So hit black oxide finish. That's going to give us, we want regular steel. And it's giving the option for us to have partially or fully threaded. It may not matter when we set the length. So our length was 800 thousandths and change. So that is about 7/8. So we have 7/8 long. We want a hex drive. And let's go up and see if it still gives us options. No, it doesn't give us the option for the partially threaded. So it's going to be, the shorter screws tend to be fully threaded. We have two products to select from. There's a locking type, fully threaded locking type, and then there's just a standard fully locking or fully threaded one. So that's what the one we're going to use. You're going to select on the part number for the black oxide standard screw and hit product details. And again, we're going to zoom down to the drawing, and somewhere there'll be a box that seems to move around for the model. So it should remain 3D SAT. We're going to save, and there's a bolt. Now we're going to hit, we're going to change the orientation of this bolt to match this hole down here at the bottom. Go ahead and pivot at 90 degrees. Doesn't have to be exact, as long as it's somewhat close. And we'll hit OK. Now we need two instances of this part. To do that, you right click on the component on the tree, and we're going to select copy, and then right click by the tree and hit paste. We're going to capture position, and there are now two bolts, two screws in the same location here. So if we move one of them out of the way, you'll see that there's a second one. I'll drag that one over to the right, and this one's going to go in the opposing hole. So we're going to rotate it 90 degrees so that it's facing the same direction as the second hole. Select OK. For these two bolts, we're going to do a rigid joint. And the reason being is once they're screwed in, yes, they can come out, but through normal use, you want them to stay fixed. So we're going to go to joint, and we're going to join the bottom of the head to the bottom of the counter bore. So by selecting the radius of the bottom of the head with a snap point that aligns with the bottom of the fastener head, that will be in the same plane as the face of the counter bore at which it would rest upon. Okay, so right there. The default is still at cylindrical, so we're going to change that to rigid, and its animation is this little shake. So it should be aligned. You have a little bit of the screw sticking out the other end. I think we did in the real version. And you can select OK. There is no motion to address on that fastener. It is going to stay screwed in and stay there. Now we're going to go back to the second fastener and repeat that procedure. Select joint, select something that's round, make sure the snap point's on the center line. Our mate type is rigid. We're going to go over to the corresponding hole. We're going to select something round at the bottom of the counter bore and snap our point to the center of the model, just there. And it's rigid. We'll hit OK. Alright, so now if we play with the motion, the screws go with the block, and we can slide our set screw around, and that should do it for your model. So if you've represented this and save it, in general I'm not going to take points off for differences in the individual modeled components that you made, but I am going to take points off if you choose fasteners that don't make sense and they're not assembled correctly. The points that were lost on modeling would have been applied to the model parts. I do encourage you to fix any issues I gave you feedback on, so you'll be more successful at this step. That ends this tutorial, and thank you very much, and we'll see you on the next one.